a deeper dive into Artemis. I'm Tonya Hall, and joining me is Dr. Jacob Bleacher, Chief Exploration Scientist at NASA Headquarters for Human Exploration. Welcome, Dr. Bleacher.
Thanks for having me. Glad to be here.
What are some of your responsibilities in your role at NASA?
I work for a team of folks in human exploration at NASA headquarters who are focused on how to make sure that our hardware that we'll send to the moon or to low Earth orbit is able to do the jobs that we'd like to see. Technology demonstrations, scientific research. In general, we call it utilization, or how we will use the hardware. And so the big thing that we're focused on right now is preparing for our Artemis program, which is the program that will carry our astronauts to the lunar South Polar region in 2024.
I'd like to discuss the Artemis program, actually. In fact, the first Artemis voyage with astronauts aboard is scheduled for 2024. Tell us about the robot visits that will occur before that.
Sure. We have a number of landings that are scheduled before that through our commercial lunar payload services. This is referred to as CLIPS. And that's run by our Science Mission Directorate at NASA headquarters. But it's actually working with commercial partners across the country. So it's an effort in which we work with those commercial partners, and they develop the landers and they carry the payloads to the surface. So NASA works with them to deliver the hardware we want to do the science and the research. And so we'll have several of these landings ahead of our human crew members that come on the Artemis 3 mission in 2024. And so those missions can go to other locations on the lunar surface. They can collect data that will help us understand broadly the context of the science work that our astronauts will do at the South Pole. And in some cases, help us understand the South Pole a little bit better so that we can make sure we're building the hardware right and that the science activities we develop for the astronauts are most effective.
What are the goals of the 2024 mission when the first woman and the next man step foot on the surface?
Well, you said it right there. The highest goal is to send the first woman and next man to the moon in the South Polar region. In addition to that, they'll be conducting a series of extravehicular activities, or EVAs, that will give us the opportunity to collect samples from places we've never been on the moon in the past. Maybe to deploy some science instruments or technology demonstrations that will help us better plan how we do longer excursions on the lunar surface in the future. So these together will be some of the tasks that they're doing. But also we'll be testing out brand new landing systems. So we have a system we're developing called the Human Landing System. And it's been a long time since we were tasked to develop a lander like this. And so we're actually working with commercial partners right now to develop these landers that will carry our crew members, our astronauts, to the lunar surface.
Why did NASA choose the moon's South Pole?
The South Pole is a unique place. First of all, we've never been there before. So the Apollo landings were more equatorial. They were on the Earth-facing side of the moon, kind of in the middle. And so we have a bunch of samples that we brought back from there, a number of observations from each of these landers. The polar regions are places that are relatively unexplored. Now, the South Polar region has potentially two resources that we're interested in using. First of all, at the South Pole, because you're at the bottom of the moon, there are places where in deep holes, sunlight never gets in. So some of the deep craters have not seen sunlight ever. But the flip side of that is that for high topography, mountainous ridges or small peaks that are high above the average terrain elevation, they see sunlight more than average locations on the moon. So during Apollo, the locations we went to see sunlight for about half of the time, but some of these locations can see sunlight for 70 to 80, maybe even 90% of the time. And so that's a resource for us. It helps us develop systems that don't need to tolerate cold temperatures for as long. It's also a good source for power generation. Now, in addition to the sunlight access that we get at the polar regions, we also believe that there is water ice trapped in some of these craters that never see sunlight. So on the surface of the moon, The sunlight helps to strip away water that may collect there or other volatile materials. But when it's protected underneath, mixed in with the surface dirt, which we call regolith, and protected from seeing the sunlight in these polar regions, in these craters, we think we can actually collect or have collected and stored vast amounts of water. So these two resources, light and water, are kind of two big reasons that we want to go to the polar region, the South Pole in particular.
Tell us about the Gateway and the role it will play in Artemis missions.
Yeah, the Gateway is an orbital platform that will be placed in an orbit around the moon. So during Apollo, our vehicle went to a lunar orbit, and then we had a separation and a command module that stayed in orbit with one astronaut, and then a lander that went to the surface and carried two astronauts. Now, in each Apollo mission, all of that hardware had to be built new for each mission. And so the command module is something that was in orbit, and we recognized that if we had a command module that basically stayed in orbit and we could reuse it, that gives us the opportunity to have kind of a way station there. And so the landing systems we're developing in some cases might be more than one vehicle. We may have several vehicles that are delivered, and they need a place that they can aggregate together. And so the Gateway would serve as kind of that command post. It stays in orbit. The elements that we send up, whether they're parts of the human landing system, maybe they're logistics resupply modules, they can fly to the Gateway, which will have a habitable environment where astronauts can stay in orbit. And that's kind of the place where we can bring everything together, rely on the Gateway for power and propulsion, and then send our astronauts down to the lunar surface from the Gateway. So eventually we'll have that build up into a position where we can use it for the lunar access, but also to conduct research about the deep space environment, which is a critical part for helping us start thinking forward about preparing for a Mars trip.
Speaking of water, you participated in an announcement about finding water in a sunlit area of the moon's surface. Congratulations on that discovery. So, where can the rest of us go to keep track of the progress and updates on Artemis?
Yeah, so you can go online to nasa.gov, and if you just do a quick search for Artemis, you'll see a number of websites that link up to the different programs that make up overall Artemis program, as well as the work that we have going on. And of course, you can always go to NASA TV to see any of the updates that we have. We tend to release videos and updates about what we're doing. And you referenced the discovery that we announced this week from the Sophia observatory, which detected a signature of water on the surface. So that's a great example of something that you can go get updates for at nasa.gov.
Thanks again for your time, Jacob. That was Dr. Jacob Bleacher, Chief Exploration Scientist at NASA Headquarters for Human Exploration. And you can find more of my interviews right here or on iTunes, Spotify, and YouTube, or go to tonyahall.net. Thanks for watching.